Greetings and welcome, friends. We've been talking about really real exponents and exponential functions. We're on page 600. Here's question 27. It tells us simplify each expression. So on 27, I've got some real exponents. All right, these happen to be irrational numbers, which we discovered yesterday were permittable to be evaluated and whatnot. They're cool as exponents. So here I've got a classic power to a power. What do I do with power to a power with those exponents? What do I do? Multiply them. I like it. So root 3 times root 12. I like it. That's going to be the same as y to the square root of 36. And what is the square root of 36? 6. So I believe y to the 6th would be the simplified version, not simplified. Although that does sound pretty cool if I was some sort of mad scientist and created like a ray gun that simplifies things. That would probably be the appropriate word. So there we go. 27, proper expo. That's all you do. 33, a little bit different here. It said, find the values of a. So this a is not the word a. It's the variable a, the coefficient piece here. It says, if the graph of an exponential function of the form y equals a times 3 to the x passes through the given point. Now, the parallel concept here with your y equals mx plus b from way back in the days of algebra 1-dom, or math 1-dom perhaps, would be back when like I'd give you the equation of a line, or I'd give you the slope of a line and a point that it passed through, and I'd ask for the equation. And you'd plug in your point for x and y, and you'd solve for what your missing information was. In that case, it was b. So here I've got a point 2, which is going to be our x, and 36, which is going to be our y. And I'm going to plug those into their respective positions, and then simply solve for a, the thing that I don't know. Plug in what you know, solve for what you don't. So 36 is going to equal a times 3 to the second, right? So that means 36 is equal to 3 squared is 9, 9a. So I would divide both sides by nu of a. And I would end up getting a, if I flipperoo this, is equal to 4.
Wait, how did you get 3 squared?
Yeah.
I plugged in the 2 for the x and the 36 for the y. Yep. So plug in what we know, solve for what we don't, is what we had to do there. And what this would allow us to do is if I had, say, limited information about a graph and I was trying to find its equation, I could then, have found the particular value at a point and, found the exact equation as a result. So if I actually asked for what the equation would be, this would be y equals 4 times 3 to the x is the actual equation that passes through that point and has, a base of 3 as far as an exponential function is concerned. So yeah, kind of a unique little concept problem right there. Let's see, let's look at 41. So here it tells us to solve and to check our solution. I've got 1/32, let's see, I'll rewrite this a little bit larger, is equal to 2 all to the 1 minus mth power. So 1 minus m, that whole thing is the exponent. And the idea we had yesterday was that if I have 2 powers that are equal and their bases are the same, then their exponents are equal. Now the question here is, I've got 1/32 technically raised to the first power. These bases are not the same. However, 1/32 you might realize can be written as a power of 2. I don't know if you realize that. Do you guys know what power 2 is? 2 to what power is plain old 32?
6.
Close. 5th, yep. And 2 to what power would be 1/32? What would I have to do to that 5? I'd have to negativize it. Negativo?
How do you do that again?
Well, I just happen to know that 2 to the 5th was 32, and 2 to a negative exponent would flip it. So I was just familiar enough with some of the powers. I mean, 2 to the 5th, that's kind of as high as you might need to know. But the idea was that given the section that we're in, the only way we'd know how to solve this problem is by trying to rewrite this and this in terms of the same kind of power as powers of 2. So I would have just kept kind of practice, like what's 2 to the 4th or 2 to the negative 3rd, or like I'd try some different things until I could figure it out. So let's see. So this is equal to 2 to the 1 minus mth power. And if 2 to this is equal to 2 to that, then this must equal that, is the logical conclusion we would make. So I could now solve this equation by subtracting uno from both sides. I'd get, I'll flipperoo this as always, negative m, or the opposite of m, more accurately said, is equal to negative 6. So therefore, positive m must equal positive 6. And that would be the solution there. Now it told us to check it. If I plug in 6 here, 1 minus 6 is negative 5, 2 to the negative 5th would be 1 over 2 to the 5th, and 1 over 2 to the 5th is the same as 1 over 32. So it does all seem to check out. No concerns there, my friends. So that's the idea. So thanks for watching, Internet friends.